Hello, it is my pleasure to welcome you to today's episode of Agricbiotech and Food Security. I am Kirian Umayo and I believe in biotechnology. On our show today, we shall be addressing one of the most challenging phenomenon in agriculture. That's pests and diseases. The damage to plants are mainly caused by viruses, bacteria, fungi, and insects. And such attacks on plants can greatly affect their productivity and in some cases can totally destroy a crop. Plant pests and pathogens interfere with the growth and cause damage to cultivated and naturally growing plants, and this results in the failure of plants to reach their genetic potential. It is a global concern, and many nations devise means of addressing pests and diseases prevalent in their own environment. So what are the challenges of pests and diseases in Nigeria? And what are the available solutions to this menace ravaging the agricultural sector? How do we harness biotechnology to combat pests and diseases in agriculture? We bring in Dr. Rose Gidado, Director of Agricbiotechnology at the National Biotechnology Development Agency, NABDA, where she has been in the vanguard of promoting application of agribiotech in the nation's food chain. Welcome to the show. I am Kirian Umayo. Our guest today on the program is the Director, Agricultural Biotechnology Department at the National Biotechnology Development Agency, NABDA, Dr. Mrs. Rose Gidado. Madam, it's my pleasure to welcome you to the program.
Thank you, Kire.
Now, our topic today is on pests and diseases ravaging crops across Nigeria. Farmers count their losses on an annual basis on account of pests and diseases which destroy large sections of farmlands. How can biotech be deployed to mitigate this challenge?
Pests and diseases are not really good for the crops. They bring in low yields, and they infest the crops and at the end inflict some diseases on the crops. Even when you harvest, you can't get the best of those crops. You can't export them. Like in terms of cotton, the lints will be colored. There'll be a lot of coloration and some will look. They're not at all qualitative. In terms of quality, it's zero. And then in terms of beans, you will see a lot of defects on the beans. Some cuts, some warts, and also coloration as well. Most coloration is all true. And in terms of maize, when you take up the maize cob, you will see maybe some area where the insect must have really, maybe try to destroy. But anyway, it's food to them. So it means that we're sharing food with them. The climate change is bringing in a lot of them, and we're all clamoring for the same food. They're looking for food. We too are looking for food. They're eating our own food. Some insects are beneficial, but those ones that come and also eat our food for them to survive and what. So they are now becoming a menace to us, a problem to us. They are causing low yields in terms of productivity of affecting the agriculture sector and our food systems and our what. And so you can't get to export because of those things. So that's why we have to find a way of developing these crops in such a manner that those insects will not have access to them. Protecting our crops, giving the crops protection against these insects.
Now, let me ask you this. Are there bioinsecticides that could be applied by conventional farmers who have already planted to ensure that at the end of this planting season, there could be reasonable harvest from their farms?
Yeah, we have biopesticides, of course. We have biofertilizers. Um, when you hear something is bio, it's a living thing that has been used to produce that thing. So most times, they are safe, of course, to apply. They don't leave any residual effect because they are biodegradable. When they go into the soil, they get biodegraded by the microorganisms in the soil. So it's only the ones that are not of bio origin. Things like the chemical fertilizer, when you apply to your crop, yes, um, it works. The phosphate part of it, other part of it, they work. But then the sulfur, the residual effects, on the soil is actually not good. And then accumulation of that residual, the accumulation of it on the soil, at the long run, also contributes to climate change, to global warming. Yeah. And some of it, when it rains, they get washed down to the rivers. And most people in the villages, they drink water straight from the river, untreated water, and they end up getting infected. So the bios, of course, the bioproducts, most of them are safe. The bioinsecticide, the biopesticides, we have them. Like when you're using neem, mostly it's trees, the trees that we know around us. You can use them to make biopesticides.
Biopesticides can then be applied
And you
on
can now use
conventional
them.
farms.
You can apply them on conventional farms. We have the cover crops. You can use them on the conventional farms. Of course, some of them have what will I say, insecticidal, elements in them. Some insects get repelled by them, and so the plants are not affected. So, if you notice a plant like that, you can actually use it to drive away some insects around your farm, and or make a solution of those insects.
Well, I have been speaking with the Director, Agricultural Biotechnology Department at the Biotechnology Development Agency, NABDA, Dr. Mrs. Rose Gidato. Thank you, Madam, for being part of our show today.
Thank you so much, Kirian.
Our next guest on the program is Professor Mohammed Ishaku, the man who played a key role in the development of BT cowpea that's now commercialized in Nigeria. Let's take a short break now. The program continues in just a moment. This is introducing a new TV series on agricultural biotechnology, one of the most complex and accurate scientific discoveries designed to provide sustainable food security for humanity. In the light of rapid population growth, Agricbiotech must be understood, accepted, and embraced to realize its full potentialities. Nigerian agriculture is vulnerable to climate change with associated occurrences, reducing agricultural production across the nation. But biotech offers new tools for increasing agricultural productivity and protection of food crops. And from farmers, testimonies abound on the benefits of genetically modified crops. In this TV series, we shall be dissecting issues surrounding Agricbiotech with experts on its understanding, acceptability, and application, week in, week out. Join me, Kirian Umaya, on our show, Agricbiotech and Food Security. Be my guest, Tuesdays, 7:30 p.m. on NT International. Brought to you by OFAB Nigeria under the auspices of NABDA. Joining me on the show today is Professor Mohammed Ishaku. Professor Ishaku is a professor of plant breeding and genetics. and is of the Department of Plant Science, Institute for Agricultural Research. He was one time the Executive Director or CEO of that institute. He's also of the Faculty of Agriculture at the Ahmadu Bello University. Prof, you're welcome to the program.
Thank you very much.
Prof is known in the biotech family as the man who championed the cause of BT cowpea, which is now making waves in the Nigeria's farming sector. He will tell us more about that. We are engaging him today to give us a clue of how we can harness biotechnology to combat pests and diseases, since he's a professor of plant breeding. What can you tell us and our viewers about pests and insects or diseases with respect to how they attack plants in Nigeria and the need to deploy biotech to fight that?
Thank you. Both pests and diseases cause tremendous loss to farmers in the field and also in storage. Diseases mostly are in the field, whereas pests persist from the field up to storage in different crops. In cowpea, using cowpea, for example, there are a number of insect pests, and when they infest, they cause very significant losses to farmers and therefore reducing the income they will be able to generate from their farming business. A number of insects have sources of resistance, and when there are no resistant varieties, farmers buy insecticides and spray on the cowpea to control these insects. It is a common knowledge that insecticides are not only expensive and therefore unaffordable to many small-scale farmers, but they can be very toxic and hazardous to both human health and then the health of the environment. As soon as you release this chemical into the environment, they go along and effect some negative impact on the environment as well. So therefore, if there is any way that scientists can avoid usage of insecticides or limit use of insecticides, it is preferred to the deployment of insecticide chemicals to be sprayed by farmers. We have tried in cowpea to control one particular insect that causes up to 80% yield loss on farmers' field. This insect is a pod-boring insect that feeds on the leaves of the cowpea. It feeds on the flower buds, and it also feeds on the developed flowers. And if flowers survive by any chance, then the pods that develop from those flowers will also be bored by this insect, and therefore rendering the pod of very low quality, and consequently it will reduce the quality of the grains that will be harvested. So that the sum total of this insect causes up to 80% yield loss, as I said earlier on. Several years ago, effort had gone into developing varieties that can protect themselves against the insects, such that they will internally fight the insect, such that the insect will not be able to survive on it. Or this is a very natural phenomenon that exists in nature. Certain plants can protect themselves against pests on their own without having to be protected. Cowpea scientists like myself and my colleagues went out to look for such cowpeas throughout. Up to 15,000 different types of cowpeas were screened for their ability to withstand this insect, but none of them turned out to have this protection. That is why, over the years, only insecticides have been found to be the most effective means of controlling this insect. The search for the alternative way of developing a variety that can protect itself continued for several years, until recently, when it was possible now to take the ability for the plant to protect itself was discovered through genetic engineering. That is the use of biotechnology tool. This method was successfully used in cowpea in the laboratory, and we were able to develop an insect-resistant cowpea variety that requires only 2 sprays to have a complete crop. Ordinarily, farmers will have to spray between 6 to 10 times sometimes, depending on the intensity of the infestation of the insect in the field. This new variety, which we developed, that can protect itself against that insect, that pod-boring insect, is 100% resistant or protective against that insect. The remaining few insects which this new gene does not confer resistance to is what is being targeted for with the 2 sprays. So farmers can now produce cowpeas with only few sprays, and which means grains of cowpeas that are healthier, with a healthier environment and cheaper to produce, is now available. This variety was evaluated, and some breeding work went into it to make sure that it is the kind of, that new variety has the kind of outlook and the taste and the chemical composition which Nigerians are looking for, and is as tasty as any cowpea that Nigerians are used to, except that it is resistant to this yield-reducing insect.
Let me ask you this, Prof. If you plant cowpea, for instance, harvest the cowpea, can you replant the same cowpea that you harvested, next year during planting season?
Yes, you can do that. If you have a cowpea seed you buy from us, you can, if you choose to, you can plant it. It will do as good as the previous one in cowpea. There is no problem. Now, when farmers produce grains, we call what has been planted from seed, we call it grain because it is largely for feeding. But if a farmer decides to save part of the seed, he can plant it and it will do. But the danger is that gradually it will be adulterated, either through neighboring cowpeas that are planted there or some volunteers that will come out with it. So we advise farmers for them to get very good germination and very good plant count and also yield, to go back and buy seeds after 1 or 2 cycles of replanting.
Are you working on other plants? So apart from cowpea, I know we're also talking about cotton, soybean, cassava, like root crops, yam, and other crops. Are we extending this research to do the other crops that are staple to Nigerians?
We are working on maize to develop the same type of maize variety that is protective against